And now I'm going to clarify a little bit about how to train a KNN model in R. Now, so the thing with R is that it has a lot of libraries, and a lot of these libraries are designed to train different types of machine learning models. So there are libraries to train, I don't know, KNN, linear regression, uh, regularized regression, logistic regression, um, random forest, artificial neural networks, whatever you name it. So there are a lot of different libraries, and these libraries, they are written by well, statisticians who work in different universities or maybe in companies, and um, the functions to train every model, so they're kind of different. So the syntax is different. Well, at the very least, sometimes, so here is, for example, the syntax to train um, a KNN model for classification. So the function is called KNN3, right? And the first argument is the formula, and the second argument is the data set. And the third argument is K here. Well, although I'm not sure, well, I guess the I'm not even sure that data should be the second argument, or maybe it doesn't matter, right? So my point is that sometimes the syntax could be different. Sometimes the data set could be first and the formula could be the second, or sometimes it could be something else even, right? So, and if everyone writes kind of their own, um, and there are also some settings like preprocessing and some other settings, and if everyone writes their own functions for training different machine learning models, then it's kind of hard um, to keep track of all these. And in order to make training different machine learning models more convenient, so some clever people, they created this library called caret, right? So it is um, loaded here, a library caret, and in caret they have this kind of universal wrapper, the function train, right? So the function trains is designed to train all models, so all machine learning models, right? So what you need is you need to tell it which type of machine learning model it should train by specifying the method, right? And now in train, so the formula always comes first. So this formula tells us that the response variable is species, and whatever comes after tilde, in this case, is dot. So dot means that the rest of the variables are features or independent variables. So then I have my data, then I have my method, which is KNN, and then there are two things. So train control. So in this case, train control is none, and tune grid. Um, in this case, the tune grid is just k equals 3. So let me explain what this is. Train control is, at the moment, we don't really know what it is, but in a couple of weeks, you will learn about it. So let me explain. So now with KNN model, so there is this number k, so the number of nearest neighbors, and um, usually you want to choose the k that um, you, there is no kind of universal rule how to choose the k. So there is no such thing as you always choose k to be equal to 5 or to 15 or whatever, right? So basically you need to choose k to make your model more accurate, right? And this is done in practice by just experimenting with different values of k. Now, tune grid allows to sort of automate this process. So if instead of just you know going with k equals 3, you wanted to choose to try different values of k, like 2, 3, 5, I don't know, then you would really change this to try different values of k, right? So I mean, we say you wanted, instead of just 3, you wanted to try 3, 5, 7, and 11, you would write something like this. Well, and train control tells you basically what should be the method to choose the optimal value of k. Now, if you do not choose the value of k, then of course the training control is just none. But if you want to choose, I mean, between these 3, 5, 7, and 11, then there are kind of different ways to do it, and you will learn about them. But what you can do, you can, for example, specify cross-validation. Again, so you will learn what cross-validation is later in the course. And there are also different ways to pre-process. So in this case, it is scale, but there are kind of other ways too. So basically, it tells us how to pre-process the data. And the convenience of this function is in that if you specify the method of pre-processing, then basically it learns the parameters of this method. So what is the mean and the maximum and whatever it is from the training data, and then whenever you feed any new um, test observations to it, it's going to construct predictions by applying the same type of preprocessing as it did on the training stage, as it learned on the training stage. All right, so it's kind of a convenient way to do it, and most of the time we are going to train machine learning models using this train function from the caret package, with a few exceptions. So this package doesn't work with some other packages designed for tabulating or visualizing machine learning models, right? So, for example, if you want um, uh, to print a nice LaTeX table um, of linear regression coefficients, then basically you should use LM rather than train. Um, if all you are concerned about is training a machine learning model and constructing predictions, then usually it's just better to use this function train. And again, we will see it again and again and again in future courses. So we shouldn't worry too much at the moment if you don't get some of the inputs of the train function.